In this video, we're going to talk about exponents, rational exponents, and turn them into radical expressions, and then radical expressions and turn them into expressions with rational exponents. So this is an all-encompassing kind of review where you are utilizing the rules of exponents. So if we take a look at our first, so we have number 1, we have 4x to the negative 2 over y to the negative 8. Here we need to recognize that we have two bases with negative exponents. In order to make this correct, our x has to move to the bottom and our y has to move to the top. So you get 4 over y to the 8th, x to the 2nd. Now, please notice that you cannot combine these two things together because they are the same, because they are different bases. So you have to leave them. This is as simplified as you can get. Looking at number 2. Again, with number 2, we have two different bases. We have a base of x and a base of y. So our base of x is to the negative 4th. So I get 1 over x to the 4th times y to the 2nd. I'm going to put this over 1 just so you can see what's happening here. When I multiply straight across, I get y squared over negative x to the 4th. Number 3. Number 3, again, notice we have 3 different bases. We have an x, a y, and a z. Here, everything has a positive exponent except for z to the negative 1. So what's going to happen there is the z to the negative 1 is going to move to the top of my fraction, and you'll get 2x z over y squared. Number 4. Here, notice how many bases do we have? We have 2 bases that are the same. We have x and we have y. So I have x and y. We're going to add, because when we multiply bases that are the same, we add our exponents. So we do x 3 plus 1, which gives us 4. And then y 5 plus 7, which gives us 12. Both have a positive exponent, so that is your final answer. Okay. Here, we have this entire thing being raised to the negative 4th power. So you can do one of two things. First of all, what I'm going to do is I'm going to go through here and I'm going to put a 1. Because every coefficient has an exponent of 1. So you can distribute this, and that would give us 3 to the negative 4th, c to the negative 12th, e to the negative 20th. And why? Because here we have power to a power. When we do power to a power, we have to multiply our exponents. So that's what we're doing. We're multiplying everything. We're not finished yet though, because here I have negative exponents and I'm not allowed to have those. So anything that has a negative exponent is going to swap either up or down. So the 3 to the negative 4th is going to go to the bottom, the c to the negative 12th is going to go to the bottom, and the e is going to come up top. So exactly everything is switching places. For number 6, we have two different bases. We have r to the 3rd, and then we have our t's. So here we're dividing bases. First up, our r to the 3rd is not getting divided by anything, so that's going to stay. Then we're going to use a division rule, which means I'm going to subtract my exponents. So t to the negative 7th minus 5 gives me t to the negative 12th. Now looking here, I have a negative exponent. I'm not allowed to have that. So that's going to move to the bottom. So I'll get r to the 3rd over t to the 12th. Looking here, we have a negative 4 exponent. So two things that you could do. You could recognize that that's a negative exponent and it's going to flip everything on the inside. Or you can distribute the negative 4 exponent. I'm going to put a 1 here and a 1 there. So distribute the negative 4. You get a to the negative 12th over 5 to the negative 4, m to the negative 4. Now we can simplify this. And recognizing that when we have a negative exponent, it switches on top to bottom. So the a to the 12th is going to go to the bottom. And both in the denominator are going to go in the numerator. Number 8. First up top, you're going to multiply your coefficients, so you get 18. Then we're going to add our exponents. So you get y to the 5th. I'm going to rewrite the 6y to the 3rd. From here, I can simplify. 18 over 6 simplifies to 3. And then here you are dividing, so that means you're just going to subtract your exponents. So y, 5 minus 3. So I get 3y to the 2nd as my final answer. All right. Take this in pieces. I'm going to simplify 4 over 8 to 1/2. The x's, I'm going to simplify. So x to the negative 2 minus 3, because we have to subtract our exponents. So I get x to the negative 5. I'm going to leave that up top for now, and I'll deal with moving everything once I get it all simplified. Here you have y to the 4th over y to the negative 2 raised to the 3rd power. So this becomes y to the negative 6. So now, that will go away. we're going to subtract, so y to the 4th minus a negative 6. That turns positive. So you get y to the 10th. Now, I can simplify one more time, recognizing that x to the 5th has to move to the bottom, and the y to the 10th will stay up top. Again, we see we have power to a power. I'm going to add a 1 to both my coefficients. Distribute that negative 2 to everything, which gives me 2 to the negative 2, x to the negative 4, over 5 to the negative 2, x to the negative 3. From here, I'm going to swap everything from top to bottom. So I get 5 squared up top, x to the 3rd, over 2 squared, x to the 4th. X to the 3rd minus, or divided by x to the 4th, will give me x to the negative 1, which will then shoot the x to the bottom, so I'll get 5 squared over 2 squared x to the 1st. And just to make it look pretty, final answer. For this one, I think it's easier to work inside the parentheses first and then apply the power to a power. So let's work inside first. So I have a to the 4th times a to the 1st, giving me a to the 5th up top, over a to the 2nd, all raised to the 3rd power. Now I have division of exponents, so a to the 5th over a squared will give me a to the 3rd raised to the negative 3rd power. Multiply, because I have power to a power, I get a to the negative 9th. We're not allowed to have a negative exponent, so that becomes 1 over a to the 9th. Okay, a lot going on here. Again, a couple things you could do. You could first simplify within the parentheses and then work to the exponent on the outside, or you can distribute the negative exponent to everything and then simplify. I think for this one, it's going to be easier to simplify within and then distribute. So up top, we're going to get 4 squared x squared y over x y to the 4th, all raised to the negative 2nd. So really all I did was distribute that. Now, the 4 squared will stay. X squared over x gives me x to the 1st. Y to the 1st over y to the 4th will give me y to the 3rd on the bottom, all to the negative 2. Now let's distribute 4 to the negative 2, x to the negative 2, over y to the negative 6. And simplify one last time. My y to the 6 is going to come to the top. 4 squared will go to the bottom. X squared will also go to the bottom. If you would like to make this a little prettier, this 4 squared will turn into 16. All right, last one. So for here, again, couple ways that you can do this. You can first distribute the 6 to everything and then simplify, or you can simplify inside the parentheses first and then distribute. Let us distribute first. So a to the negative 6th, b to the 18th, c to the 6th, over a squared b to the 4th. Okay. Very important here that we recognize that we have 3 different bases. Okay. So you have a, and we're dividing, so it's going to be negative 6 minus 2. You can use a to the negative 8th. Then we have b to the 18th minus 4, giving me b to the 14th. And then we have c to the 6th left by itself. Okay. Notice the only thing with a negative exponent is the a. So that's going to drop to the bottom, leaving me with b to the 14th, c to the 6th over a to the 8th. Okay, so from here, what we're going to do is we're going to turn each rational expression, or base with a rational exponent, and we're going to turn that into a radical exponent. A couple of things I want you to recognize is that here we have a to the n over m. This is our fraction. Now, this fraction, our exponent, do have 2 different things. Our numerator does one thing, our denominator does another. So notice here in rational form, rational exponential form, we have a to the n over m. Now, as we transfer that into radical form, my m becomes the root of my radical, and the n stays with the base underneath the radical. So as an example, here we have a to the 2/3. Draw my radical. The 3 will go to the outside. That's my root. And my a squared will go to the inside. I can't simplify this because you cannot take the 3rd root of a squared. There's not enough to take out of it. Here we have 64b, all raised. This entire thing is being raised to the 3/4. So what we're going to do is we're going to draw our radical. The 4 will go to the outside, and on the inside we'll get 64b to the 3rd. Now I know that I can simplify this, so let's do a little bit of work. Okay. First, we're going to distribute, so I'm going to get 64 to the 3rd, b to the 3rd. Now, I know that I can break this down. And I know that I can break it down in terms I'll be able to simplify it. So 64, I know, is 2 to the 6th, which is this. 64 is the same as 2 to the 6th power, raised to the 3rd, b to the 3rd. Okay? Now follow along. Take what you know about power to a power. So I get 2 to the 18th, b to the third. Now simplify under the radical. 4 goes into 18 how many times without going over? It goes in 4 times. That means I can pull out a 2 to the 4th. When I do that, I have, so 4 times 4 is 16. So I get 2 squared left. You can't take the 4th root of b to the 3rd. So that is your final answer. Looking at our next example, 25x to the 1/2. I need you to recognize that these are 2 separate things. Therefore, we can rewrite this as 25 times x to the 1/2. Notice that the 25 has its own exponent. So we get 25 to the 1st times the square root of x to the 1st. This can be pushed together, so more clean would look like this. 25 square roots of x. Now, difference is that this is in parentheses and the entire thing is being raised to the 1/2. So we can write that as the square root of 25x all raised to the 1st. Now, when anything is raised to the 1st power, it is what it is. Nothing changes. So I get the square root of 25x. But this can be simplified. Why can it be simplified? Because you can take the square root of 25. The square root of 25 is 5. So the 5 will come to the outside. You cannot take the square root of x, so that remains under the radical. And you get 5 square roots of x. Again, as we look here, notice we have 27a to 2/3. The 27 is by itself, and the a is the one that has the exponent of 2/3. So I can write this as 27 times the cubed root of a squared. Push these two things together. So you get 27 cubed root a squared. Here, difference. This entire thing is being raised to the 1/3. So, cubed root 27 a to the 6th, all being raised to the 1st power. Distribute that 1, nothing changes. So I get the cubed root of 27 a to the 6th. The cubed root of 27 is 3. So we use that. That's done. 3 goes into 6 twice. So, and it goes in twice evenly. So we get a squared. That goes away. No more radical. That is your simplified answer. Now we're going backwards. Now we are going to go from radical form and put it into rational exponent form. So again, remember, we have, if this is m and that's n, then it's going to look like that in exponential form. So first one's easy. We have our base. 3 is our root. 5 is our denominator. Simplify if you can. Here, we don't have to. Okay. I'm going to distribute that 4 to what's underneath. So I get 2 to the 4th, c to the 4th. Now, because there's no number for our root, we assume a 2. I'm going to try and simplify these as much as possible prior to putting in to rational exponential form. So 2 goes into 4 twice. So I get 2 squared on the outside. 2 goes into 4 twice. So I get c squared. I can clean this up. 2 squared is 4, so I get an answer of 4c squared. All right, square root of 36x. If I look at this, I have nothing under, I have no rational exponent, or like there's nothing underneath. They both have an exponent of 1. Here I'm going to take the square root. Well, I can take the square root of 36. The square root of 36 is 6. So that goes away. We don't have to do anything with that. Then we're going to take our x and go 1/2. Okay. Here our 6 is already on the outside, so we don't have to do anything with that. We have the square root of x with a rational exponent, that's x to the 1/2. We can squish these together, write it more cleanly as 6x to the 1/2. Okay. The cubed root of 8b to the 5th. I'm going to take the cubed root of 8, which gives me 2. And then with my variable, b to the 5th, I'm just going to write as 2b to the 5/3. And just leave it like that. That's the best way to do it, is just to leave it just like that as 2b to the 5/3.